This video lesson, what we're going to do is talk about graphing quadratic functions written in vertex form. In our previous section, we focused primarily on standard form being ax squared plus bx plus c, where we have our three terms. Again, the quadratic term, which is the first piece. You have the linear term, which is the second piece, and then the constant term, which is our third piece. So written there, again, standard form, there's nothing really special about it. It's just how all basic quadratic functions are written. Vertex form, however, is a little bit more particular. Obviously, by the name, in this function, you're going to have the vertex given to you. So it's going to, again, look like this. We introduced this in the first section. You have y equals, that's our output, a, and that a value, just like in a normal quadratic and standard form, a is going to be that value that's going to make the graph either skinny or wide or maybe flip it upside down. And then you have times x minus h squared. So notice I have my square. So what's happening here is it's taking this quadratic term and adding to it. So instead of just x squared, you have the x minus h. Essentially what's happening is this is a result of a process called factoring that we're going to learn about later on this chapter. We still then, so notice we have the x minus h. So h again is going to be another number. That h value is going to represent the x coordinate of our vertex. Okay, now because it has the x minus h, that's how it's written, but we talked about this in our first section that h value is going to be the x coordinate of our vertex, but we're always going to look at the opposite. So for example, if it said x minus 2, even though it says minus 2, the h value is just simply going to be 2. So it's always the opposite of what's shown in there. And on the outside, you have plus k. So plus k is going to be our constant term at the end, that c value. But in this case, that c value is going to represent the y coordinate of our vertex. It's going to shift that graph up or down like we talked about at the very beginning. So an example of something written in vertex form would be 2 times x minus, let's say, 3 squared, and then plus 4. So in this case, I will know right away that my vertex will be at a point of 3, 4. So when graphing this is going to be a little bit easier in terms of the process of trying to fill out my table of values and plot the points. Because if you're given it in vertex form, you know automatically from the start where your values are going to be centralized, okay? What is going to be the middle values of my graph? And again, it's going to form a parabola centered around that vertex and that axis of symmetry. Now, if this is written in vertex form again, vertex form will be a times x minus h squared plus k. So you'll notice here I have y equals, in parentheses, x minus 3 squared plus k. So to compare what I have here, I have x minus 3 squared, and that's essentially it. Now, comparing the other values, my a value in front here is technically a 1. And plus k, notice there is no plus k at the end. So that means, just like we talked about in standard form, that my k value is going to be 0. Now, the important part here is based on this formula that tells me my vertex is going to be at a point of 3, 0, okay? I'm going to get the 3 from this value because it says minus 3. My x value is going to be 3, and because there's no value here, it's a 0. My k value will be 0, so I'm going to have 3, 0 as my vertex, which is automatically going to be the middle value of my graph or of my table. So I can then choose points around that value of 3 to then plug into my function. And now my function's a little bit easier to plug into. Start, for example, with 1. I would do 1 minus 3, and whatever I get there, I'm going to square it. And again, just like we did in standard form, we just got to plug in all of our inputs because this value where I plugged in 1, that is my x, that is where all my inputs go. So if I plug all these values in, I'm going to get my outputs. And I'm going to get the pattern of 4, 1, 0, 1, 4. Now I can plot these points starting with 3, 0 on the x-axis. Again, my axis of symmetry would be the vertical line going through that point. So if we want to still include that, we can. And notice the values on my table. I have the pattern of 4, 1, 0, 1, 4. It's repeating itself. So when plotting those points on my graph, you should recognize it forms that nice parabola, that nice U shape, where those points are equal distance on both sides of the axis of symmetry. So in vertex form, again, it's going to be a little bit easier because we're given the vertex, and then all we have to do is fill out our table of values based on that. Next example, I have 2 times x plus 4 squared. So again, comparing this to vertex form, I have a times x minus h squared plus k. Here I have the 2 times x plus 4 squared. Notice there is no k value like we said before, which means my k value is going to be plus 0. 2 is my a value, and then h would be that value next to x. Now, thinking about this, what is my vertex? So vertex form is going to give you the vertex. This is one where notice it says instead of x minus h, it says plus 4. So this is where it's important to recognize that we are going to take the opposite. So it says x minus h, I have x plus 4, which means that my h value is going to be the opposite of positive 4, so negative 4. And then my k value again at the end is 0. So my graph is going to be centered around negative 4, 0, where negative 4 is my x and 0 is my y. So that means my axis of symmetry again is going to be found at negative 4. And then all I got to do is plug these values in. Knowing I'm at negative 4, 0, I'm going to plug these values into my function where I see x. So y would equal again 2 times x plus 4 squared. And where I have this blank is where you guys are going to fill in those inputs. And our inputs are going to be centered around negative 4. So I would have negative 5 and negative 6 on the low end, and negative 3 and negative 2 on the high end. So plugging those in, I'm going to get 8, 2, 0, 2, and 8. Now you'll notice compared to the last graph that we had, the pattern of 4, 1, 0, 1, 4. Notice now that when I add in that a value of 2, do you see how my values double? 2, 8, 0, 2, and 8. Because that a value is going to take my points and double them and stretch this graph out. So instead of at 1, I'm going to have 2 on both sides. And then this is going to be all the way up to 8 instead of being at 4. So notice now, compared to the last graph, my parabola still symmetrical around that axis of symmetry, but is going to be a little skinnier. All right, so now I have 1/2 times x minus 5 squared. So looking at the vertex here, my vertex based on the equation is going to be at a position of 5 and 0. Again, it says minus 5, but we want to take the opposite. So on my table of values, I know it's going to be centered around 5, 0. Tells me my axis of symmetry is going to be found at 5. So now picking points around 5, I would have 3, 4, 6, and 7. So then my goal would be to plug those values in where I see x and to find my output so I can plot my points. And what I get is 2, 0.5, 0 again is my vertex, 0.5, and 2. So again, compare this to that pattern I had originally, 4, 1, 0, 1, 4. Notice all these are cut in half, and that is because my a value in this case is the 1/2. So plotting these points, I would have 3, 2, 4 1/2, 5, 0, 6 1/2, and then 7, 2. And again, it's going to make my parabola, and compare this to the very beginning. This parabola is going to be a little bit wider. So that 1/2 is going to shrink it down a little bit instead of stretching it out. All right, now I want you guys to try this one on your own. So I have negative 3 times x plus 2 squared. So identify where the vertex is, fill out your table of values, and plot your points. Go ahead, try this one on your own. All right, so my vertex would be at negative 2, 0. Then centering my values around that vertex, I would choose negative 4, negative 3, negative 1, 0. Inputting those into my function, I'm going to get negative 12, negative 3, and then negative 3 and negative 12. And notice that my graph is flipped upside down because of the negative. And then that 3 is going to stretch out the points. So again, compare that to the 4, 1, 0, 1, 4 that we had in that first problem. Notice that it's not only negative, but it's also stretched out. Those values are 3 times bigger than what they normally would be. All right, next couple examples here. Now we're going to throw the whole kit and caboodle at you. So now comparing this to the whole vertex form of x minus h squared plus k, we now have the function of negative 2 times x plus 2 squared plus 3. So you notice you have the a, the h, and the k. We're going to do this the same way. We're going to identify our vertex. Here's the only difference. My x value would still be the opposite of what's shown, so negative 2. But now I have a k value. Notice my k value says plus 3. Okay, so that's that constant term thrown at the end. So that means my vertex is no longer just going to be at negative 2, 0, but it's going to be at negative 2, 3. I'm still going to follow the same pattern of centering my graph around that axis of symmetry, or around that vertex, okay? So I got to choose some values to the left and right of -2. So let's say -4, -3, -1, and 0. And just like before, I always want to plug these in for my input. So I have, instead of my x, I'm going to take each of these values and plug them in where x goes and evaluate each of them. Nice thing about vertex form, unlike standard form, is notice that when I have the full vertex form equation, that I only have to input x once instead of twice. And for my outputs, I would then get -5, 1, 3, 1, and -5. So now I can plot my points. Now my vertex is now shifted left 2 and up 3. So notice the 2 and the 3 are going to tell me where that vertex shifts. And then filling out the rest of the points, I would have -3, 1, as well as -1, 1. And then I would have -4, -5. And same thing here, 0, -5. So I'm going to get my parabola. And notice again, it's upside down as well as stretched out. So you see here that -2, it's not only flipped upside down because of negative, but my vertex is a little bit skinny, so it's stretched out because of the 2. And then these two values are going to tell me where my vertex is going to be located. So nice and easy. All right, 2 more examples here in vertex form. I'll do this one, and then you guys got the last one on your own. So here we have 3 times x minus 1 plus 6. So my vertex is going to be located at 1, 6 based on my function. So that means my x value be 1, y is 6. I then want to choose values around 1, so say 2 and 3, and then 0 and -1. And my goal then would be to plug those into my function where I see x. So I have the x minus 1 squared plus 6 with the 3 in front, so I'm going to plug those values into that spot for x and get my outputs. In my outputs, I'll get 18, 9, 6, 9, and 18. Again, centered around that vertex that we got from our function. Plotting these points then, -1, I'll put my axis of symmetry, forgot to do that before, so we're at 1. I know my vertex is going to be at 1, 6, so I know that point. So now plotting the rest, I have 2 and then 9. I have 3 and 18, which I can't plot on this graph. And I also have 0, 9 on the other side. So know that my parabola, because I'm running out of space here, doesn't go all the way up to 18, would be a nice skinny graph pointing upward. And again, it's skinny and upward because of that 3 in front is going to stretch that thing out, and it's positive, so it's going to be facing upward. All right, last example I want you guys to try on your own. You get the 1/2 in front. You have the x plus 4 squared minus 2. So identify where our vertex is, fill out your table of values, and plot those points on the graph. Alrighty then, so my vertex would be at -4, -2. And then plotting my rest of my points, my outputs, I would get 0, -1.5, -1.5, and 0. Plotting these points again, I have my axis of symmetry and my vertex, and then I have my points on either side. The 1/2 again, it's positive, so it's going to be facing upward, and that 1/2, you'll see the points kind of crammed in here, is going to shrink my graph down and make it a little bit wider. All right, so again, this was graphing quadratic functions in vertex form. Hopefully you found this a little bit easier than graphing it in standard form. Again, if you have any questions, jot those things down, and we'll see you guys next time.